Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. In the previous session, we have discussed about what is graph introduction, and we have seen about under graph introduction, we have discussed about what is the terminology of the graph, and we have seen about representation of graphs. These are the two things where we have discussed in the previous session, right? Once you can look into that video so that you will be getting some clarity about what are graphs, okay? And in this session, we will be discussing about the types of graph traversals. And under that, we have two categories of graph traversals. Those are breadth first search and depth first search. About this, we are going to discuss. And one of the example we will be seeing is breadth first search example, how we are going to implement it. Okay, let us see the graph traversal. What is the use of a graph traversal? What we are going to do with this? Okay, graph traversal is nothing but it is a technique for searching vertex in a graph. In a graph, we are going to have the vertices and edges, right, as we have discussed, and by using this graph traversal, we are going to search whether a particular vertex is there in the graph or not. This one we are going to do in the graph traversal. And the graph traversal is also used to decide the order of vertices is visited in the search process, in which order you want to traverse, in which order you want to traverse through your graph. That is also going to be decided based on this graph traversal. And another one, a graph traversal finds the edge to be used in the search process without creating any loops. When you are going to use these graph traversals, when you are traversing through the graph for searching any particular vertex, and it should not form any loops. Without forming loops, you have to traverse your graph, right? That means the graph traversal will visit all the vertices of the graph without getting into the looping path. You should not form any loops, what I said in the previous statement, the same thing. And there are two types of graph traversals are there. One is breadth first search and another one is depth first search. These are the two graph traversals where we have. Let us see the first graph traversal, what we are going to do in the breadth first search, and let us see what is the algorithm, what it consists of, and let us discuss one example with it, right? Here, breadth first search traversal. In short, we are going to name it as BFS. BFS of a graph produces a spanning tree. At the end of the BFS traversal, it is going to produce a spanning tree. What is a spanning tree? We will see this. We will discuss now. Spanning tree is nothing but it is a graph without forming any loops. Any loops we should not form in the spanning tree. As we had discussed in the previous point also, the graph traversal should not form any loops while searching. Here also the spanning tree, whatever the result you are going to get it, by traversing through your graph, you should not get any loops while traversing through your graph, right? And here, what is the data structure we are going to use when you are going to use the BFS traversal is the queue data structure. Again, at the time of applications also we have discussed this. This BFS is going to use this queue data structure at the time of discussion under queue concept, right? Queue data structure with the maximum size of number of vertices in the graph to implement BFS. And the size of the queue also depends on the number of vertices what you are going to have in the graph. And let us see, these are the steps where we are going to implement our BFS traversal. Let us see the steps, then we will see the example. First, we need to define the queue size. Why? Because for BFS, we are going to use the queue data structure. That's why we require a queue. Queue size of number of vertices, total number of vertices in a graph. First, we need to define one queue and select any vertex as the starting point. You have different vertices. Suppose you have given some 5 vertices. Among that, you can select any vertex as the starting point for the traversal. Then, visit the vertex and insert it into the queue. When you are going to visit a particular vertex, suppose I have visited A, right? This is going to be placed into the queue, right? We are going to insert that into the queue, right? Now visit all the non-visited adjacent vertices of the vertex which is at front of the queue and insert them into the queue. Suppose I am going to have some adjacent vertices for this, like this way. A, B, C and D. These are the adjacent vertices where I am going to have, just assume, right? Based on this, whatever the adjacent vertices you have, those things we are going to place it into the queue and we are going to move front. That means we are going to remove this particular visited vertex from the queue. That is the meaning of it. When there is no new vertex to be visited from the vertex which is at the front of the queue, then delete that from the queue. That means the same thing. What are the adjacent vertices you have? We are going to place it into the queue. If you don't find any adjacent vertices after placing them, then we are going to remove it from the queue. And repeat 3 and 4 steps until queue becomes empty. That means we need to place all the non-visited vertices into the queue based on whatever the vertices you have placed. We need to check for the remaining also. If you don't have any new vertex that has to be placed into the queue, just we are going to remove them, and until this has to be repeated, your queue becomes empty, right? When queue becomes empty, then produce the final spanning tree by removing unused edges from the graph, right? At the end, what we are going to do is, the main result of BFS is we need to produce a spanning tree, right? And how that spanning tree has to be produced? By removing unused edges from the graph. Which of them has not been used in your graph? That means which of them you have not traversed, right? The path which you have not traversed, or which of the edges you have not selected. Those things has to be removed, and then we need to produce the spanning tree. That is the meaning of the last step. Let us see this example what we are going to do. And this is a graph with the total 1, 2, 3, 4, 5, 6 and 7 edges we have, right? Now, what is the first step we have? We need to have a queue with size of the number of vertices. That's why we have taken the size as 7. Okay. Now, I have selected the starting vertex as A. This is my starting vertex, right? Now, insert A into queue. Whatever the vertex I am going to start, that has to be placed into the queue. This one I have placed, right? Now, in the second step, what are all the adjacent vertices for A? Check once. What are the adjacent vertices you have? B, D and E. These are all the adjacent vertices we have. All these adjacent vertices we need to place it into the queue. While placing, you can place them in any order. Either I can place it like this, B, E, D. You can place D, B or D, E, B. Any order we can place, no problem, right? Here I have taken the order as a D, E, B. These are the 3 adjacent vertices I have. I am going to place them like this, right? Now visit all the vertices of A which are not visited and insert newly visited vertices into the queue and delete A from the queue. After inserting all the adjacent vertices, we need to remove A. This was discussed as in the algorithm also. Next, now from this, what is the first? You have D. D is the vertex where you are going to be there in the queue. Now from D, you check what are all the adjacent vertices you have. From D, you have A is there, E is there, right? Only 2 are there. A is already visited. A is already visited and E is already placed into the queue, so that we should not bother about it. Visit all the adjacent vertices of D which are not visited, but there is no vertex which is not visited, so we are going to delete that from the queue, right? Next, after deleting D, you have E, right? Now from E, you check what are all the adjacent vertices we have. You have A already visited, you have B already visited, that is already placed in the queue, and you have C and F. These 2 vertices are not visited, that are not there in the queue, so that we are going to place them. Either we can place it in any order. You can place CF or FC, anything. FC or CF, anything you can place it in the queue. Now after placing that, we need to remove it from the queue, right? We have removed E from here. Next, and the next one where we have is, we have B. From B, check what are all the adjacent vertices you have. From B, you have A, C and you have E, all are there, right? And so that there is no vertex to be visited, no vertex, new vertex that you are going to find, so that we are going to delete the B value also. And the next one where you are going to have is the C value. From C, what are all the adjacent vertices you have? From C, you have E is there, G is there. F is already placed, right? C and F and G, in this F is already placed, so we are going to insert G into the Q, okay? And so that after placing G, we are going to remove F. First we are going to remove C and then we are going to remove F also. And then from here you are going to have F. From F we are going to check, is there any non-visited vertices? No. Any adjacent vertices which are not placed into the Q? No. Everything is placed, so we are going to remove the F value. And then at last we are going to left with the G. For G, you don't have any other vertices which are not visited, so we are going to delete that G value also. Now Q becomes empty, so stop the BFS process. Now we are going to stop it. After removing all the vertices from the Q, we have to stop this process. Final result of your BFS is a spanning tree as shown below, right? In this way, how you have moved your graph, based on that way you are going to get this spanning tree, right? This is how where you are going to get your spanning tree. Now the overall summary what we have seen is, we have already discussed this graph traversals, right? What is a graph traversal we have seen. Under that graph traversals, we come across two graph traversals, BFS and DFS, and what is the main purpose of graph traversal we have seen, and the example on BFS also we have discussed. I hope you understand this concept. If you have any doubts, please do comment in the comment section, or if you have any queries, please do it in the same comment section. Thank you. Could I understand this concept? Still, if you have any